Welcome, and thank you for standing by. All participants are in a listen-only mode until the question-and-answer session of today's call. At that time, you may press star 1 to ask a question. Today's call is being recorded. If you have any objections, you may disconnect at this time. It is my pleasure to turn the call over to your moderator, Catherine Hambleton. You may now begin, ma'am.
Thank you, and good morning. I'm Catherine Hambleton with NASA's Office of Communications. Teams conducted a wet dress rehearsal Monday, June 20th at NASA's Kennedy Space Center in Florida to validate the timelines and procedures for launch, including loading propellant into the rocket's tanks, performing the launch countdown through the handover to the automated launch sequencer, and draining the tanks. NASA has reviewed the data from the rehearsal and determined that the testing campaign is complete. The rehearsal is the final major test needed before launch, and now the agency will roll the SLS and Orion back to the vehicle assembly building next week to prepare the rocket and spacecraft for their next flight test. Apologies. Here to talk with us about the path ahead are Tom Whitmire, Deputy Associate Administrator for Common Exploration Systems Development at NASA headquarters, Phil Weber, Senior Technical Integration Manager with Exploration Ground Systems Program at Kennedy, John Blevins, Chief Engineer for Space Launch System Program at NASA's Marshall Space Flight Center, and Cliff Lanham, Senior Vehicle Operations Manager, Exploration Ground Systems Program at NASA at Kennedy. After a few brief opening comments from each of our speakers, we'll take your questions. So first we'll go with Tom Whitmire.
Okay, thank you, Catherine. First of all, yes, on Monday we had the wet dress rehearsal, and as you know, Tuesday we had a chance to talk to you early on about our initial thoughts coming out of that test. Since that time, we've had Charlie and a lot of folks at the Kennedy Space Center have had a number of people looking at very specific data from the test and the results of the testing, the parameters that we got. And then we had a meeting to discuss that, and we had all our folks involved in that meeting. And at this point, we've determined that we've successfully completed the evaluations and the work that we intended to complete for the dress rehearsal. As a reminder, this is one of many tests that we've conducted at KSC, as well as tests that we've done at Stennis and an earlier test in our umbilical test facilities. And it's something that we're building knowledge up incrementally over time. So when you look at each of these activities, you have to kind of also compare them to other activities that we've done. And for example, for the wet dress rehearsal, we knew that we would never actually turn on the engines or start up the rocket, and therefore it was designed really to rehearse things like the loading operations and the detanking operations, and really took a look across all of our sites to make sure that people had the right information and working together. We'll get into some of the details of what we talked about, a little bit more information from Tuesday. Phil's going to be able to provide you some more details of the data that we collected and what came out of that. John will help out with that as well. And then Cliff later on, he's our flow director. So on the conclusion of completing the wet dress rehearsal, I basically told Cliff to get ready, that his job would be to prepare the vehicle for launch. And so when we get back to the VAB, Cliff will tell you what he's going to do that. We'll talk a little bit about the quick disconnect leak. Well, Phil has actually a very strong background in that area. He'll be able to talk to you about that. But we think overall we got really good data from the wet dress rehearsal. We've had a number of opportunities to do this. The team has really become proficient in how to actually handle the vehicle and work together. And we're hoping that this will put us in a good position when we get ready to attempt launch opportunities. So we're doing one more test at the pad. They're going to talk to you about the test that's taking place later today to pick up one of the items we weren't able to do during the actual rehearsal. And then the vehicle will go back into the VAB. And as I said, we'll have Cliff begin the process of preparing the vehicle for launch. And with that, I'm going to turn it over to Phil Weber.
Okay, good morning. Can you hear me okay?
Yep.
Okay, very good. So my name's Phil Weber, and I am not Charlie Blackwell-Thompson. Charlie's the launch director. She sits up in the front of the room, and she is the one that's really in charge of the whole launch operation. My role, I sit back at the integration console, and I'm the console chief there. We have about a dozen of us at that console, a mixture of NASA and Jacobs folks. And our primary role there is to work through problems and issues as they come up. We lead the technical integration of problem resolution for anything that goes a little bit off nominal during the countdown. We've also got the ground launch sequencer at our console position, and that's the computer system that monitors the launch commit criteria and also does the critical sequencing and commanding in terminal count. So that's what we do, and that's where I'm from. So yeah, I'll tell you, I was actually floating on cloud 9 when I drove home Monday after the test. It was a long day for a lot of us, but we stuck with it, and we got all the way through. We got the vehicle completely tanked, core stage and upper stage into stable replenish on all commodities. We did have an issue with the 4-inch QD that we'll talk a little bit more about. And we did work that one pretty hard, trying to come up with a solution to see if we could get that to seal up for us so we could effectively do that bleed function. And what that is, we have a habit of talking in NASA speak, and I know it's probably simpler to break it down a little bit. The bleed function is where we take liquid hydrogen from the core stage and flow it down through the engine section to cool down the inlet of the engines. And the thinking is, the criteria is you've got to have the engines at a specific range of temperature and pressure in order for those engines to start. And so we really had two different things going on in the middle of the tanking. When we're up in stable replenish, we went ahead and tried to activate that bleed function, and we found that we had a hydrogen leak. In reality, the guys were on top of it. The guys and gals, I'll be honest, the liquid hydrogen operator's a female. She tracked it and opened the vent valve on the core stage hydrogen tank in time. So we got 3.9% hydrogen. So we were underneath the 4%. We didn't break the launch commit criteria for the leak. And then we worked that pretty hard for, like I said, we exercised it in a similar fashion to what we did at Stennis, what the Boeing and Marshall team did at Stennis, and what we had done previously down at our launch equipment test facility, where we wring out all these umbilicals. And that consisted of closing up the fill and drain and closing the bleed and evacuating the liquid out of those lines and purging them out and warming it up, basically, right? So the liquid hydrogen gets that down to in the range of negative 420 degrees Fahrenheit. So we warmed that up to near ambient, and the thinking being you can get that QD to move around and maybe reseat itself and seal up. And then we went back and opened up the valves and got back into flow, brought up the bleed again, and had the same problem. We still had the leak. So we brainstormed that and troubleshot and thought about it, and then eventually got to the point, we're kind of burning daylight. So let's go ahead and bite the bullet. We'll close that bleed valve and go ahead and we can mask that in our ground launch sequencer, which means basically, you've probably heard us talk in ground launch sequencer language. If you mask a measurement, the sequencer is still monitoring it and will still show that we got a hit, but we won't stop the launch count for it. And we'll brief the test team ahead of time to not call out the failure. So we put that into a mask mode. The bypass is where you don't look at it at all, and basically you're not even going to see the hit. So in this case, we used it in mask, and so we had to go talk through with the mission management team because we had to mask a couple of our launch commit criteria in order to get us all the way from 10 minutes and counting all the way down. And so we put together that technical rationale. John Blevins and his team from Marshall came forward and supported with the technical rationale. Our team exercised the options over in Fire Room 3 on the emulator to make sure that it would really work and that we wouldn't have any surprises pop out during that execution. So then those guys ran back over from Fire Room 3, got back into position in Fire Room 1, and we picked up the clock at 10 and made it all the way down into ALS, the automated launch sequencer, which was really the prize for us for the day, right? We got all the way down through terminal count, and we got into the automated launch sequencer. We expected, because we had masked the engine start launch commit criteria, as soon as it got into ALS, it was going to break us out, because in the ALS, it looks for that same measurement. And we don't have the capability to mask it on board. So that's exactly what happened. 29.98 seconds, ALS cut, and then RGLS cut off at 29 even. We went back and so I was feeling really good because I thought we got, the vast majority of what we're looking to get out of the day. Tuesday, I think there was a press conference, and we had said, Charlie and Tom and the team said we're still looking at the data and evaluating. After we got through looking at all that data on Tuesday, it was even better than what I expected. What we found was that we only had 13 of the 128 commanded functions that we planned in terminal count that didn't get successfully accomplished. And we looked through those in detail with the subsystem teams, and it turns out the majority of those have already been validated in prior tests. For example, like the arms and umbilicals retraction, we commanded that using the ground launch sequencer when we did the umbilical release retract test. So we've really already validated that function. One of the other things we ran into, I think you may have heard us talking about, was the liquid oxygen feed line heaters. Those are the big, long vertical pipes that run down the outside of the rocket. It's a kind of an interesting phenomena, but the bottom of that feed line, it's such a long vertical column that the temperature stratifies, and you get a pretty significant temperature difference down at the bottom of that feed line. And so it's kind of the opposite problem of what you have with the hydrogen. In that case, you've got the liquid oxygen that gets too cold. And so you'd be outside of range for the engine start due to the liquid oxygen being too cold. So there's a set of electrical heaters that are basically mounted onto that feed line, and we power those from the ground. They don't serve any function in flight. They're basically just to get you into the right range to get the engine started. And we had problems with those. We'd turn them on and try to control them, and they would just shut themselves off. So we had to, that basically fed into the same kind of the masking of the launch commit criteria. We knew we were not going to be in the start box. That's the temperature box for temperature and pressure for getting the engine to start. So since then, we've actually dug into that software and looked at the control parameters that we had. We believe that we don't really have any kind of a design hardware issue on the ground system. We think that it's within the command parameters and the software itself. So we've already got a good head start on getting that fixed. So I think that one's going to be relatively easy. But anyway, we looked through all of the commanded functions that were planned. Another big piece of this for us, and probably something that a lot of people don't think about, is the safing operations, right? So when you get this thing fueled and you've got the ordnance connected and the safe and arms into the arm position, you really got a tiger by the tail, right? And so if something does go off nominal, you've got to make sure that you can actually safe the vehicle and keep it under control. And of the 72 GLS commanded functions planned for the WDR, we got all but 3 of those were successfully accomplished in this test. And again, those 3 were related to the arms and umbilicals. Just because we didn't get that far, there was no way to safe them at that point. And again, those were the tests that we'd gotten through back in the VAB, so they'd already been accomplished. The other big nugget for me is that of all the launch commit criteria that we talked through, we had no additional mandatory LCC violations detected in terminal count. We did take one hit on an Orion issue, but we had a pre-planned contingency for that. So if it had happened on launch day, we could have held it 6 minutes and cleared that one and gone. Looking through all of our other requirement set, we're really not finding anything in our data that would say it would have stopped us. So I'll tell you, from my perspective, we're going to get back to the VAB. We've got a good strategy to go work on this 4-inch QD and take it apart and inspect it and get it back together, get some confidence that that's going to work right, and then we'll head back to the pad for launch. We are going to do I think Tom had mentioned the booster hydraulic power units. Because we cut off at 29 seconds, we never got far enough into ALS, the automated launch sequencer, to turn on the booster hydraulic power units. And so John Blevins and his team came forward to us on Tuesday and said, hey, we'd really like to go exercise those things. And I'm going to hand off to John to talk a little bit more about the logic of that. But we said, yeah, we understand and that makes sense, and we'll fit that in since we've already got the hydrazine loaded. We're well positioned and postured to do it, and now would be the right time to go get that. So anyway, we're shooting to get back to the VAB sometime July 1st, July 2nd kind of time frame. And Cliff's going to talk a little bit more about what's coming up for him once we hand the vehicle back to him and the VAB team. And with that, I'm going to hand it over to John Blevins.
Hey, thanks, Phil. Good morning, everybody. Always good to hear Phil's voice. Actually, he's the one I work the most with on a launch day. for sure. My team did take a look after the wet dress, and we looked at everything that we planned to get and what we got and what we didn't get, and the things that were left after the T minus 29 second cut, as Phil said, that we expected once we decided to go into mask mode regarding that 4-inch QD. So what we came up with was that ultimately there were no hugely significant things, but we decided that the hydraulic power unit, you guys that were on Tuesday in the press conference heard me mention that was one of the things on my list. It wasn't one of the major goals of the test, but it is a component that's pretty easy to test. We have procedures should something have been replaced on those components to do that on the pad, and so we're going to exercise those scripts and capability through the ground side to do that. As Phil mentioned, the components are fully loaded with the hydrazine that we use. Let me just describe those components just a little bit. The hydraulic power unit ultimately it's an APU that has turbines on it, 2 turbines per booster, and it basically powers the hydraulic pressure for each booster to gimbal the nozzles, right? And so in this case, as you guys most likely know, the boosters provide about 80% of our steering force through the ascent flight to the boost phase. And so the component is extremely robust. The function is extremely important. And so we just want to spin that up and look at the speeds, and we can do it without much cost and time. And so we're gonna do that. The hot fires themselves, we call them hot fires. This is a hydrazine decomposition. They happen about 16 seconds per booster. We'll do those boosters separately. That's something that would be concurrent in the normal flight software, but for our ground functioning, we're going to do them separate boosters. And you will not see anything. There will be no fire and smoke. These are self-contained in the outskirts of the boosters, but they'll last about 16 seconds. There will be a slight gimbal to the engines, probably not detectable by the human eye unless you're very astute. It's plus or minus 1 degree, so it's not like the gimbling that you might see on the RS-25s when we spin those up. But we'll power those up. There's again 2 turbines per booster, and those that are attached to the pumps that will provide the gimbal for the booster nozzles. Basically, these components are heritage. In fact, these components have flown on the shuttle numerous times, on the boosters for the shuttle numerous times, and so we're very confident in these components. But again, they're a critical function. They're just something that my team and myself wanted to check out, and we're in a state where we can do that. And so it's not a required test, and so we talked a lot about that because we tend to do just what's required sometimes. But it is a good engineering test, and it mitigates some risk of a launch opportunity because should it malfunction in that last terminal count, you've got a fully tanked rocket, and if you miss the velocity or speed in there, you have nowhere to go. And so you've spent a lot of time to get to that point. So I think it's a great mitigation for us, and that's what we're going to do. And I'll pass it over to Cliff, who I think is going to talk about where we go from there.
Okay, thank you, John, and hello, everyone. So as you heard, we will have some work coming back with us into the VAB that we're starting to plan into the overall plan, as well as our planned work that we always knew was going to be required once we come back from WDR. So once we get back into the VAB, the teams will get into the process of establishing VAB access. So that'll mean extension of the 10 sets of platforms, as well as starting to install access kits into the different volumes of the vehicle. Some of the additional work that we would be doing would be vehicle inspections, working on the hydrogen leak, the 4-inch QD, perform late stove Orion payloads. We have an avionics box R&R that we need to complete on the ICPS. We have a software load in addition on the ICPS. We will also be installing the flight batteries on the core stage, the booster, and the second stage. We do have some FTS flight termination system hardware that we need to change out as well. And then ultimately, we want to get to our flight termination system testing. And once that's complete, we'll be able to perform our final inspections in all the volumes of the vehicle and do our closeouts. So that's kind of the VAB look. I guess from the next week look ahead, We've talked a lot about the HPU hot fire that'll occur tonight. And then also this weekend, we plan to do an ambient leak check to characterize that 4-inch bleed QD before we leave the pad. Once that's complete, we'll deservice the hydrazine from the aft skirts starting Monday, and that is expected to go till Wednesday. And then we'll get into our final preps of for rollback, which will be configuring the vehicle. We have facility disconnects to perform, ECS configurations to change, and then also the crew access arm rotation into its roll position. And then we'll also be finalizing our CT preps and getting the CT up under the mobile launcher. As Phil mentioned earlier, we are planning for a Triple Balls 1 Friday, July 1st as first motion, and but that will be dependent on how the weather is playing out and what the forecast looks like. And then we do plan to be back in and hard down into VAB on Friday. As far as back to the VAB side of things, we are expecting to spend roughly 6 to 8 weeks of work in the VAB, but that's notwithstanding any final, as we do our vehicle inspections, and any findings we may have could alter that plan. So overall, the team is ready to get back to work in the VAB. We're looking forward to it, to get all the closeouts and get the vehicle ready to roll back out for launch. And so with that, I'll hand it back over.
Thank you, Cliff. We'll now begin the question and answer portion. You can enter *1 on your phone to be entered into the question queue at any time. Your phones are on mute now, and the operator will open your mic when you're ready and close your mic after your question. We ask that you please stick to one question and identify to whom your question is directed. And if we have time, we'll allow reporters to ask a second question. And you can press *2 to be removed from the queue if your question is answered. So we'll start with Bill Harwood from CBS News.
Hey, well, thank you very much. A couple of, I know, one question, but it is one question, but it has two parts. On the 4-inch QD, if you don't find anything obvious in that QD when you take it apart and look at it, in other words, you don't find a fault, can I assume you're simply going to put it back together and you'll roll out and hope for the best, or if you don't find a fault, you try to do something more invasive? And the related question is, if you roll back out and you still have a leak, regardless of how you're there, is that something you would attempt to work on at the pad, or is a leak like that, grounds to roll back for more extensive looks? Thanks.
Hey, Bill, the second part of your question broke up. If you could repeat the second part.
Actually, I got it. He was breaking up, but I understand where he was going with it. Hey, Bill, this is Phil Weber. Tip Talone says hi, by the way. So yeah, if you go out and Google "Summer of Hydrogen" and my name, you'll find a little interesting 5-minute read on what we did back in the 90s chasing hydrogen leaks. So not my first rodeo on this one. And you're right, we could get back to the barn, pull the umbilical plates off, and pull the QD apart, and the seal may look good. I'll tell you what we're thinking on this one. It turns out that the Teflon seal that's in that QD was the same one that was used at Stennis, and so it's got some runtime on it, as well as a couple trips to the pad. So we're expecting we're going to go in and change out those soft goods, and we're still talking with John Blevins' team about while we're in there and got it apart, probably maybe makes sense to go after the 8-inch soft goods as well. That's the fill and drain line. If we do get out to the pad and, knock on wood, everything's going to go well, but if we do end up finding that we still have a hydrogen leak at that time, this is an area that we do have access to out at the pad. It's something we can do at the pad if we need to, and what that would do is it preserves the number of rolls that you have to do back and forth to the pad, and it could probably fit better. Our team's been looking at that. It's a little bit sporty because you got to build up an enclosure around that whole area to try to keep it clean. Keep the Florida salt air and dirt, and we get thunderstorms about every afternoon, so it would be a challenging thing to go do at the pad, but we do believe we could do it if we had to, and I think that probably would be what we'd be looking at rather than rolling back to go after this one. And I'm kind of talking about John Blevins He's the design authority for this hardware, so probably better to have him weigh in as well. Typically, you know, I can tell you what we're going to do and how we're going to do it, and then John would tell you why we're doing it that way, right?
You know, I'll just put an exclamation point on what Phil said. We're going to do exactly what Phil said, and Phil and his team are really experts at this. I would also say, Bill, you used the word hope. I would say it's an informed, educated hope, if we're going to use the word hope, because of what we've learned over decades of using hydrogen, and Phil's team has a lot of that experience, as well as the design teams that I get to help lead. Bring to bear. So yeah, Phil's got exactly right. We're going to go change those soft goods. If we don't see a witness to that, that doesn't mean that those soft goods aren't the culprit there, and they've got experience. So I concur with Phil.
And we carried this forward to Tom Whitmire's board meeting on Wednesday. That's where the actual formal decision was made to break config and say we're done with WDR based on all the data that I kind of summarized earlier. But we did talk through that. You know, what's the relative risk of, you know, because hydrogen systems are tricky. You can test it at ambient and it passes fine with helium, and then you get cryogenic hydrogen in there and you end up finding that you have a leak sometimes. But what I told Tom and the rest of the community from my doing this for 37 years is we're really not in any different posture than we were with the space shuttle. Every flow, we would mate the orbiter, and we'd mate the tail service mast umbilical plates to the sides of the orbiter, and we'd do a ambient temperature helium signature test, looking for leaks. They would be tight, and then we roll to the pad, and then we put cryogenics in it, and most of the time it works. So that's where we're at. We're really not in a much worse risk posture than we would have been for pretty much every flow.
Yeah, that's really well said. You know, Bill, the thing that really caught our attention is we saw repeatable performance of the seal during the testing that we were doing at the pad, and also the fact that looking back now, we hadn't changed the static seal since Stennis, and that would be a potential rationale right there. So that's something good to go after. Cliff, did you want to talk a little bit about how we get to that seal? It's actually kind of straightforward once we get into the VAB.
Right. What we'll do is we establish access. We have access stands that'll go in, and then we'll demate the umbilical plate. So we'll pull that back, and then obviously then we have access right there to get into the umbilical on the flight side, or the QD on the flight side. Now, like Phil mentioned, we do expect to put an enclosure around it to from a contamination standpoint. So we'll have to build that up as well. But yeah, so Tom, it's it's access that we can very readily establish.
Yeah, we don't have to go into the engine section or something. So the good news is it's an easy to get to spot right on the base of the ML. That's easy to get in there, relatively easy. Nothing's overly easy. It will require some work, but that was also a good indication for us. And I agree with Phil. Based on the shuttle program experiences, based on what we saw at the pad, based on our knowledge of that seal and how often it's been used, this seemed like the right path, and that's why we made the decision that we made. It
really started leaking when we went into what we call the kickstart, where like I said, the hydrogen operator would close the vent valve on the top of the core stage hydrogen tank to elevate the pressure. And that's what stimulates to get the bleed going and get to dump the hydrogen through the engine inlets and then out through this bleed line overboard. And that's when we saw the leak. And then when we opened up and vented the tank back down, the leak went away. So it's kind of telling, because this is meant to be a pressure activated seal. And in fact, when we applied pressure, it actually leaked. So I think we got a pretty good trail to follow on this one. The other piece is, after we do get done mating that umbilical plate back up, there's a pretty significant retest that we have to do, because it's not just these quick disconnects for hydrogen, but there's electrical and pneumatic systems that go through that as well. So we're going to rerun the interface verification tests on that end to end, just to make sure that we didn't disturb or damage anything else in the process of fixing this.
All right, thank you. Our next question is from Seth Bornstein from AP.
Yes, thank you. This is for Phil. Just you mentioned that 13 of the 128 functions you didn't get enough data on the test, and that majority of those that had already been validated in previous tests. When you take those out the number that would have been validated in previous tests, how many do you have left? And and then when you test the booster hydraulic power units, so how many would you have left after those?
Yeah, so the only of the GLS commanded functions during terminal count, the only ones that hadn't been validated in prior testing using the ground launch sequencer is what we call the dead facing requirements, and that's where we de-energize the ground power supplies, and you want to do that right before disconnecting the umbilical. And the reason is you don't want to do a hot demate of an electrical power on the off chance that you have hydrogen or oxygen in the vicinity. So we did not get a test of that. Everything else has already been tested. The reason we're not really that worried about the dead facing requirement is that you actually have to have a couple of failures for that to become an issue. You have to have some kind of a hydrogen leak in that area to begin with. You have to lose the purge that we apply through that plate gap. And then you have to have enough of a spark, energy level to create an ignition source to begin with. So we feel pretty good, and that really was the only set that we didn't get validated.
Thank you. Our next question is from Philip Sloss of NASA Spaceflight.
Thanks. I think this is probably for Tom. How much of the, from a programmatic standpoint, how much of the flight readiness review process is still in front of the enterprise? And then, Cliff was talking about 6 to 8 weeks in the VAB to get ready to roll back out. Does that still leave you with the possibility of making the, I believe it's launch period 25 that starts in late August? Thanks.
Yeah, let me answer both questions. One, we've had a number. We do what we call an incremental review of the status of the vehicle. So, at a program level, we've had a number of what we call pre-FRRs, and so we've really kind of cleared the path for most of the data that we would need to evaluate it at this point in time. And so, our goal is to every time we validate something or check something off, is to actually take credit for that. So by the time we get down to my FRR and then the agency FRR, which would take place just prior to launch, we will have most of that discussed and confirmed. So we think we're in good shape. We think we've got closed out most of the things that we can close out to this point. We'll review some of that at these meetings, but we think we're really in good shape, and we're really not working any major technical issues at this time. It's strictly a matter of completing vehicle processing and getting ready to do a launch attempt. But I want to be realistic with you. We could learn something when we get into the VAB. We could learn something when we get back at the pad. We always try to be careful to recognize that there's still a path in front of us. But in terms of the data we have today and the information we're working with today, we feel very comfortable that we're on a good path to get through the FRR process, and unless we learn something new between now and then. In terms about the windows, we really aren't able, we really need to get this back to Cliff. He needs to take a look at it. We'll take a look at the umbilical. We do have some work we'd like to complete. I also have a responsibility to work with my senior leadership here in the agency, my boss, Jim Free, and the folks here at headquarters to talk to them about that status. At that point, they'll evaluate that, and then the agency will be in a position to provide a specific estimate on launch dates or to attempt. So, right now we still believe that we're in the end of the August timeframe, that's still on the table, consistent with what the administrator had talked about previously. And if you look at our timeline, we're pretty much about where we said we would be at this point in the process. So, we feel getting through the wet dress was a major milestone for us. It gives us some confidence that we're still on a good path. But we won't be able to answer that specific question until we complete some work back in the VAB, take a look at some of the hardware, make sure there's absolutely nothing we're missing, and then we actually would talk to senior leadership here, and if they're comfortable with our position, then we'll go ahead and set the launch date. So that's, I know Catherine will probably be a few weeks down the line. When we get a little closer, we'll make sure Catherine is letting you guys know, so you'll have that information as well.
All right, thank you. Our next question is from John McCarthy of USA Today.
And thank you, you just answered it.
All right, thanks. Our next question then is from Stephen Clark of Spaceflight Now.
Thanks for doing this, and thanks for taking my question. I think my question is more focused on, what happens when you get back out to the pad. How long is that flow from the return to the launch pad until you're in a position to start the 2-day countdown? Like, for WDR, it was a couple of weeks. Is it the same length of time for the launch campaign?
So even though I'm supposed to be channeling Charlie today, I think it'd be better for Cliff to talk about that one.
Thanks, Phil. So I believe right now, based on the first time out at the pad for WDR and our run that we just went through, Charlie is off looking at her timelines. I would say that we are still in that time frame of 10 to 14 days, I'll call it. I don't want to necessarily get in trouble with her, but I know she's looking at it. So I think we're still in that ballpark, but I know they are looking to refine it. They have learned a lot over these last WDR runs and are expecting to, potentially pull back some of that time.
All right, thank you. Our next question is from Chris Gabehart of NASASpaceflight.com.
Hi, a quick question about what you just talked about there when you get back out to the pad with a 10 to 14 day pad stay. How is that sort of jiving with the 20-day clock for the flight termination system? If I understand the timelines correctly, once you activate that, it takes about 7 days to be ready to roll, and then a week or two at the pad. Wouldn't you be past that period where the flight termination system is valid from a range perspective, or are there waivers where you can go over 20 days on that? Thank you.
Let's see, Cliff, do you want that one or you want me to take it?
You can start it, Phil, and I can add to it if you want.
Yeah, we'd actually look at that one pretty hard with the range, and we got tailoring to allow us to go up to 20 days. And we laid out, and that was really based on our timelines that showed what we expected to do from the time you do the range safety end-to-end test in the VAB. The end-to-end test is where you put the hat couplers over the antennas and actually simulate the signal coming into the range safety system. And then you're not connected up to the ordnance, but you do measure the power output to verify that it will actually function if commanded to do so. So from the time that test happens in the VAB and like Cliff was describing Charlie's nominal pad flow, we laid out that in order to get 3 launch attempts that we would need 20 days. And so that's still what we're tracking to. And the range has agreed to the 20 days.
All right, thank you. Our next question is from Ken Kramer of Space Up Close.
Oh, hi, thank you. Well, just to follow up on that, 20 days, so when does the 20 days start, actually?
The 20-day clock starts when we begin the test in the VAB. So it's important that we actually get through that test in an expeditious manner, and then we have some closeouts to do after that test is completed. So yeah, we're going to be hustling to get out of the barn.
Yeah, and we're going to have, when we get a little closer to setting the date, we'll sit down and Charlie will be back and we'll go through all that with you and really kind of give you the detailed timeline. And we're comfortable that we have a plan in place that will allow us 3 launch opportunities. We'll arrange with a range to have the date set aside for us. And if you look at statistically, that's a good opportunity. And once again, I got to be careful to say that this will be a first time launch of the vehicle. We may learn something when we get out there. There might be some other things. I think when we get together next, my boss Jim Free will be here, and he'll kind of make sure we set good expectations for that. But I can tell you from a logistical perspective, they'll talk to you about that. They'll give you the specific timeline, and the way it works is we'll time the roll to support the window, and that we would have 3 attempts. We're pretty comfortable with that.
All right, thank you. We'll take another question from Philip Floss of NASA Spaceflight.
Thanks. I had a couple questions of some things that we heard about in and around run number 4. I think one of the things was with the crew access arm, which was left extended through the test. Is that going to be a factor in work in the VAB and getting ready for launch? And then we also heard about a low reading during a resistance check on one of the HPUs in the left FRB. Is that going to be an issue that needs to be dealt with in the VAB as well? Thanks.
So the config, when we get ready to come off the pad, we retract the crew access arm back and pin it against the side of the tower. Then we roll back, and when we get just outside of the VAB, we stop and then extend the arm around up adjacent to the Orion. And the reason we do that is there's not clearance once you're inside the VAB for that arm to swing around. But we do want that white room up against the Orion so we can access the spacecraft once we're back inside the VAB. And what was your second question, Philip?
Jeremy Graber was talking during the broadcast about a low reading during a resistance check.
Oh, yeah. Okay. So, yeah, we picked that one up actually before we got into the tanking meeting Monday morning. Seems like a lifetime ago, right? But so, yeah, about 4 o'clock in the morning on Monday, and it was on one of the booster HPU systems, and it's a high-pressure overboard bleed valve. It's a solenoid valve, right? And so the way the solenoid works is you energize a coil, and it pulls a magnet back and opens the valve and allows it's in the hydraulic system, not in the fuel system, not in the hydrazine system. But part of the built-in test that we run on that, it's an integrated script that we test all the systems out inside that HPU system, the hydraulic power unit, and we picked up a low resistance reading in one of these coils. And it was reading somewhere, John, you helped me out, it was like 20 ohms, should have been at least 24. Went back and talked to Northrop Grumman and the booster element folks at Marshall, and they said, hey, in reality, that's good down to 16 ohms, and the vendors actually tested it down to 13 ohms, so we think you're fine. So we went ahead and processed a waiver through the mission management team, and they actually bought that off and approved it right at the tanking meeting itself before we left and went back down to the control room.
Yeah, just to follow what Phil said there, you know, the parts themselves, the spec is about how much amps, how much current goes through the parts. And so when we do that resistance check, you know, that gives us how much current will go through. We've got lots of margin to the max current that would go through there, even with a slightly reduced resistance. And the min spec is 24.4, and it was around 22. So it was just outside of that. We did clear it for wet dress. We will exercise this and get a measure when we do the hydraulic power unit test tomorrow morning bright and early, or, well, it won't even be bright yet, but it'll be early. And we'll also check it out when we get back to the VAB to see if we're concerned about that.
Thank you. Our next question is from Irene Klotz of Aviation Week.
Thanks. These are for Phil. Two technical questions related to the wet dress. The first is what was the issue with the Orion, and the second is the software fix that you're planning to implement to address the lock speed line issue. Is that something that could have been handled real time if this was an actual launch, or would that also have scrubbed a launch attempt?
Okay, so first part had to do with what happened with Orion, and there was a specific command data handling launch commit criteria. It was turned out that this one was really not applicable for our wet dress rehearsal, but it will be applicable during the actual launch. Had to do with the video playback unit on board Orion. And what had happened was the day before, we had run a special test. The JSC guys had worked a test where they turned on some video cameras inside of Orion. And when they wrapped up and finished up, they didn't close out the files that those videos were stored to. Think like an MPEG video kind of a thing. And so when we go in and run our script, it looks to see that we've got the videos up and running. And the way it does that is to look to see the number of open recordings, and that one hadn't incremented because they were already open. In reality, we've got a pre-planned contingency in that launch commit criteria. So we would have held at 6 minutes, and our avionics guys would have looked at that. We'd have talked it briefly, probably not even go to the anomaly loop since we have a pre-planned. They'd have executed that, we'd have cleared it, and picked up the count and pressed on through if it were to happen on a real launch day. And then your other question was lock speed line heaters. I am optimistic that if that was the only thing that was holding us up, we probably could have uncovered and we would have had the right folks digging through the code of the ladder logic within that programmable logic controller and the specific parameters and set points that we had set. And to be honest, this is a relatively easy fix for us. So I believe that, yeah, it turns out now on the wet dress rehearsal, even if we had gotten this one fixed, because we couldn't get the 4-inch QD to go into the high pressure bleed, we couldn't have got the engines into the engine start position anyway. So we knew we were going to be, cutting off it at 29 seconds. Does that answer it?
Thank you. The next question is from Marcia Smith of spacepolicyonline.com.
Thanks so much. I'm curious about the statement that Jim Free made last week when he said that he would want to see every situation run to ground before committing to launch. And obviously you do still have a handful of issues in front of you. Is it fair to say that you feel that you have run to ground all of these issues and it's just a matter of a few tweaks here and there, and that's why you feel comfortable proceeding?
Yes, Marcia, we, Jim's my boss, and we sat down with him. We went through in detail everything we just talked to you about. He's on a trip to Europe right now, and this was not, this was after we had the opportunity to review the data, as Catherine mentioned, and go through everything we just talked about today. So we did go through that with Jim, and he did give us the go-ahead to proceed. So this has all been coordinated with Jim Free, and we had a lot more data, after when we get to Wednesday, we were able to get more data and talk to Jim about that. Mike Bolger, Phil, and I talked to Jim, and he agreed with the direction we gave the team.
For the ones that are still kind of hanging open, we have got some additional mitigation steps put in place where once we get into the launch countdown and get into tanking, for example, we're going to go ahead and most likely we will go into the pre-press and exercise that bleed and dial in so that when we get into the terminal count phase, we will actually already have the parameters that we need. That's something we were really wanting to do during WDR and we didn't get to. So what we talked about was doing that earlier in the launch count once we get into stable replenish, and that way we won't be under the gun with the clock counting inside terminal count trying to dial it in. Similarly with the LOX D-line heaters, right, we're going to go ahead and exercise those earlier in the tanking just to make sure that we've got them dialed in and right so that there won't be anything that'll bite us late in terminal count. So I think, yeah, my perspective is we've got the right mitigations in place, Tom.
Yeah, I agree with that, and that's a good point, Phil. Marcia, it's a combination of the commands that the handful of commands that we've actually exercised separately, and then there was basically some fine tuning, and we talked to Jim about this. We went back into the timeline and moved some things up a little bit so we would have a little more time to do the fine tuning. So it's a combination of those items, and we went through that with Jim, and that's where the basis by which we're proceeding and getting to the launch effort.
Thank you. Our next question is from Jeff Faust of Space News.
Good morning. Question probably for Phil Weber. Besides replacing the Teflon seal on the quick disconnect, you planning any sort of other, preventive maintenance to fix things that might cause a problem later on, simply based on the experience you've had with that quick disconnect seal? Thanks.
Yeah, so it's going to be more than just pop it open and swap out the seal and put it back together. We're going to take it apart and take a lot of measurements, do a lot of imagery, and there's the potential that we may pull the ground half of the QD that has a bellows in it with like a spring function. It's what actually forces the QD together to create the compression to make the seal. So we may take that off on the bench and use a tool to measure the compression force itself. And if that's a little low, maybe we'll swap that out with one that has a higher compression. It's a similar kind of things to what we did on the external tank with the hydrogen vent QD that occasionally leaked on us. So yeah, we're going to follow pretty much the standard playbook to go attack this one.
Thank you. Our next question is from Chris Gapehart of NASASpaceflight.com.
Yeah, thank you. So I know you guys don't have a launch date yet because you need to get back to the VAB and ascertain the technical readiness of the vehicle. But once you do say, okay, the vehicle is technically ready, we can look to set a date. I'm curious what your logic is going to be when you look at the 2-week-long launch period where you've got on either end sort of shorter windows of 3 to 5, 9 minutes, but in the middle of the window, you've got nice 2-hour-long launch windows. Are you going to try to set yourself up so that those 3 attempts over the week are in the 2-hour window, so you're giving yourself more time to potentially work through issues that might come up on launch day, or would you actually go for a very short 3-minute launch window right off the bat with a new vehicle?
I can start that, and I'll let the Phil kind of follow up as well. Well, that's a good Charlie question. If she was here, she'd do a much better job than I'm about to do. There's actually a whole bunch of things that they're looking at as they begin to evaluate what's the best opportunity within the window. Of course, we want to give Cliff some time to finish up the vehicle, so that would be good to kind of give him some time if we have it. We look at what's available with the range, and that's a process that, we're trying to see what dates we have available to us. Different dates have different conditions associated with them. The actual amount of the duration of the window itself is a less of an item for us because most of the things that we would work through is we try to get ahead of the game and actually, we have instantaneous windows often with the space station launch opportunity. So it's not so much and Phil will correct me on this in a second, but there's a lot of different factors that they look into to try to come up with the right time frame within a window to get the launch. And obviously, we've talked to you about, we'll time the roll against those opportunities. We want them close enough together that we can stay within our range criteria, but far enough apart that we can actually replenish the vehicle and get another opportunity. It's a science. I'm not the scientist on this one. Charlie is the scientist. And so that's probably the best explanation I can give you. But I'm sure when we come back together again, Charlie will be with us, and she'll provide you a much better explanation than I did. Bill, do you have anything else you want to add to that? Or
You covered it really well. Charlie and Mike Seraphin, our mission manager, both are kind of equal partners in going and getting with the range and blocking out the time. I know, from Charlie's viewpoint, she would always prefer to have a full 2 hours at her disposal just to work through any kind of problems that might come up. And, it's worth noting, in full disclosure, we haven't done a great job in our WDR getting started on time, right? So if we're 2 hours late getting started tanking, we've lost our 2-hour launch window. So Charlie and I are getting together next week to go start pounding out exactly what we can do to go make sure that we get started on time on the front end. A lot of it has to do with, some of our facility systems. You guys know what happened with Air Liquide and the supply fans that we use to pressurize the ML and the environmental control system room down below. So it's stuff that, we think we can go shore up between now and launch to get a higher confidence that we'll start on time. And then like Tom said, that's a big piece of it. But Charlie always prefers to have more window at her disposal. Just we're going to have some colas and some cutouts. That's just the way it is. And so she's absolutely the best one to talk to you about that specifically, though.
Yeah, and I've just been reminded, they're going to penalize us if we don't spill us out of colas, collision avoidance type of thing. So there's all, Phil's right. And it's actually a very interesting process. It's very multiple factors that they got to look into, including if we launch in certain time frames, we have known objects that we would have to not be able to launch within that time frame to avoid them. So I'm with you. I'm highly nervous in trying to answer the question because the best person in the world is actually Charlie and Mike Seraphin together, and they'll both be with you next time, and they'll be able to do a better job answering your question.
Thank you. That's all the questions that we have in the queue. So thank you all for joining us today. You can listen to a replay of this teleconference online by visiting the Media Resources tab at nasa.gov/Artemis-1 in about an hour. And to follow along with updates, please go to the Artemis blog at blogs.nasa.gov/Artemis.
And we have a web article out now, too? Or?
Yep, we actually just put a web article out summarizing the objectives and the analysis and the path forward as well. So you can find that at nasa.gov/Artemis-1 as well. So thank you again, and that will conclude our call.